Stephen Bailey, Franziska, Kirstein, and Kris Verdonck. And first up will be Professor Stephen Bailey from the Elon University in the US, from North Carolina, I think. He's an exercise physiologist, and he also teaches at the university as a professor of physical therapy education. And he's mostly interested, or his research interest lies with the relationship between the brain, physical functions, and the exercise performances. And he will show us or give us a little insight with his talk on one of his former studies on this. So welcome to the stage, Professor Stephen Bailey. Give it up. Yes.
Thank you. Thank you for that introduction. As I get my slides set up, I will share with you that my first interaction with VUB occurred at a professional meeting of mine at the American College of Sports Medicine meeting, and it was someplace in the United States. And I got to meet Ramon Meeson, who was the head of the Blitz laboratory here, and for a long time. We've known each other for quite a while. And after we talked, we had similar research ideas, and that research idea that I'm going to talk about today is actually an outgrowth of our original thoughts. Later that evening, I did spend time with Ramon and learned what it meant to be Belgian. So anybody that doesn't appreciate that, Ramon is a small guy who can handle his beers. So sort of my slide set. Do I need to do something? Okay, we're getting that set up. I'm going to go ahead and start talking. I apologize. There we go. And then I go. Okay, great.
Yep.
Great. Thank you so much. So the topic that I'll be addressing, which is highlighted in the title here, is we're going to talk about the use of a carbohydrate mouth rinse as a way to mitigate the effects of mental fatigue by measuring a physical performance measure, which we're going to use here as corticomotor excitability, and I'll define that as we go forward. This project is a collaboration of 3 universities, includes my university, shown here in the bottom right, Elon, as well as here at VUB, Bart Rulins especially has been a great collaborator for mine. And then I use, from a food science perspective, I have a colleague, Keith Harris at North Carolina State University, and he's been a great resource at providing many of the materials that we need. I borrowed more than a few of my slides today from Kevin DePaul, which you've seen Kevin present. Kevin is integrally involved in the Robotics project here at VUB, and I bring this up for a couple of reasons. One, if we look at this, because as Kevin shared this with me, he highlighted all of the identities here on the bottom of the page. I don't think my pointer is working well on the screen. Interacting or describing the interaction of all the different types of groups of people that you need to utilize to be effective researchers in the area of robotics. In terms of research strategies or foci, the group of robotics focuses on many things, including bionic prostheses, occupational exoskeletons, which we'll talk a little bit mainly about today, industrial cobots, and the way robotic control systems interact with people. So, and we're going to focus sort of on the latter of these, of how the condition of mental fatigue can influence that interaction. This is also another slide that I borrowed from Kevin, and it's a description from a paper that they published that describes the roadmap from going from in-lab assessment of different robotics through in-field assessment, and then eventually gravitating towards large-scale adoption in hopefully an industrial environment. And after talking about this for some time with Kevin, we kind of landed on where are we right now with this process, and we're probably somewhere in between the in-field assessment and the large-scale adoption of exoskeletons in robotics. We have lots of examples of exoskeletons in robotics being used successfully in industrial environment, but do we really understand what the human consequences are? I bring this up to remind us that we should be cautious, and this is an old story that occurred in the United States around a medication called Vioxx as a warning. And Vioxx was an anti-inflammatory that was used by physicians mainly to treat people who had pain that was going to result in probably a knee replacement. And it was very successful at reducing the perception of pain. But after looking at the data more closely and after the medication was being sold worldwide, the cardiovascular risk and the increase in cardiovascular death associated with that medication was delineated, and it was removed from the market, not completely. I think it can still be prescribed here in Europe, and now it's resurging a little bit in the United States for specific purposes. But this is why we need to be cautious in our application of how we want robotics and exoskeletons to exist in human culture. So we're going to talk a bit about exoskeletons to start with, and to introduce our idea of what we're trying to investigate in this particular study. So the first question may be, well, why are we even interested in exoskeletons? Why are they valuable? And this is a publication from Kevin's group, and which describes the prevalence of work-related musculoskeletal disorders in people that are working in industrial setting. And as you can see, if we look over here on the table on the right, we can see that that there is a high prevalence of injuries of the back, the shoulder, neck. They're all above 50%. So these are very prevalent, and so you could argue that the value of exoskeletons has helped to reduce that risk of injury. It's also really important for us to understand that there are all different types of exoskeletons, and they present themselves in many different ways. The picture on the right is a military exoskeleton. You can see how instrumented it is, how armor-like it is, if you want to say, how much it's designed to improve the ability of that physical person to perform physically. On the left, this is an example of an exoskeleton that's being used in a clinical setting for somebody who's got difficulty walking. I think this person suffered a challenge relative to stroke and is using the canes as well as the exoskeleton to facilitate walking. Similarly, when we look at occupational exoskeletons or ones that are being used in industry, we have to understand that they'll present in all sorts of different ways and be designed to be specifically purposeful for that environment. On the far left, we've got an image of a drilling operation or a dredging operation, and the way we're not really showing the exoskeleton, but it can be used there. And on the far right, we have a more industrial, I believe this is a fabric-based facility. And so the types of exoskeletons we're going to want to use in different industries is going to vary quite a bit for lots of reasons. So one of the questions we want to ask ourselves is, if we're trying to combat this risk of injury, do exoskeletons solve all the problems we want them to solve? And here is a short video of a project that they did over in VUB, where they were looking at the value of passive shoulder exoskeletons, and do they actually mitigate the perception of fatigue when somebody's asked to do things overhead. One of the really important things we need to appreciate about this is that proper mechanics are necessary even if somebody is not using, or even if they are using an exoskeleton. On the left, we have somebody who's completing this task in a way that we would suggest that they shouldn't, because this increases the risk of shoulder injury, lifting overhead. And on the right, this is what we consider to be appropriate technique. But we have to remember how these exoskeletons are actually used in these industrial settings is very important to us. But do these solve all the problems we're curious about? And I'm having a problem advancing all of a sudden. I wonder why I don't do that. Okay, we'll try to go down here. So here is a slide that represents the perceptions that people have when they either did or didn't use an exoskeleton. The non-exoskeleton condition is identified by the black line, and the exoskeleton condition is identified by the blue line. And you can see on the left, if we just look at how hard they feel like they're working, there's really no difference between the two conditions, whether they're wearing the exoskeleton or not. And then on the right, when we look at the perception of discomfort or how difficult the task is, we see actually higher levels of perceived discomfort when somebody used the exoskeleton. Now, there's lots of things we don't know about this. We don't know, will experience with the exoskeleton change the perception of the person? Will they become more effective at using it? Will they become more efficient? Will their perceptions be different? But the thing we have to understand is that we can't expect the things we identify with discomfort in an industrial setting to go away automatically when we introduce something like an exoskeleton. So the other question we want to ask ourselves is, well, can anything impact how these occupational exoskeletons actually work? And this is another study from Kevin's group where they looked at the impact of creating mental fatigue on how well a passive back exoskeleton works. And so they had a design, as shown here, where you can see that they evaluated the perception of fatigue. They had the person complete a dual task where they evaluated their function, and then they asked them to complete a task, either a Stroop test or a documentary. And the Stroop test is designed after doing it a long time to precipitate the perception of mental fatigue, and then they completed the dual task again. And the question was, okay, even when people are mentally fatigued, do we positively impact their performance? Here is the example of the dual task that they used, where the person is asked to pick up a weight and put it on a table in front of them within the lines that are provided. Those little white lines on top of the frame you can see on the right of the table on the right. And at the same time, they were asked to do math. They started with the number 1,000, and they had to subtract 7 from the number. So the first number would be from 1,000 to 993. Then they would subtract 7 again, 9,846, and they would continue to do that over and over again. So they were being distracted cognitively while they were trying to complete the physical task. Well, here are some things that we see. If we look, if we focus on the right, we can see this is the comparison between the situation where they didn't use the exoskeleton, the orange dot in line, and when they did use the exoskeleton, the blue dot in line. And actually, and the measurement here is how long it took them to complete the task, and it actually was a little bit worse with the exoskeleton environment. So these people, their performance was negatively impacted even when they used the exoskeleton when they were mentally fatigued. And this is a question we'll continue to have. Another question we may ask ourselves is, do exoskeletons work differently? Do we see different outcomes from different exoskeletons? And this is the last piece of research from Dr. DePaul's lab, that I'll share. Here they compared two exoskeletons. The one on the left is Shoulder X, and the one on the right is called Skell X. And they are, there's lots of similarities, but there are some subtle differences in them. And then they looked at how effective they were at improving performance. And this slide is very important because in the next slide, I'm going to show you how their performance was impacted in a lab environment, and then the last two columns are associated with how they did when they were actually in the work environment, okay, or in-field environment. So the first three, we see the improvements that they were able to document in their outcome measure, and the Shoulder X did do better than the Skell X at improving performance when people were in the in-lab environment. However, when we were in the in-field environment on the far right, we can see actually they did a little bit better with the Skell X. So the important thing is that we need to evaluate the function of these exoskeletons, both in an in-lab environment as well as in the in-field environment, and that will inform us of how effective they are. But I'm going to move on to my topic now, and I'm going to talk about the value of a nutritional stimulant. One of the things I want you to appreciate is that the perception of exercise science on nutritional supplements has changed over the last several decades. This is a reference to an article that was published out of the place where I completed my PhD at the University of South Carolina. And they published a paper, and if you look at the date, this is published in 1988, where they were able to establish that consuming, while you were cycling, a 6 or 12% carbohydrate beverage improved performance in the heat. And just so you know, that why we have a lot of studies with drinks that are 6% is because guess what? Gatorade is 6%, 6.4%. 12% is more like the amount of carbohydrate you would find in a soda like Coke. And the 6% beverage was much more effective at improving performance. Another thing I want you to value or appreciate is that as I think about these ideas, relative to how they're applied in a clinical environment, as also as well how they're applied in a robotics or exoskeleton environment, because we are beginning to envision new ways of using nutrition and not necessarily nutrition like I'm going to consume this nutrition. It's going to provide me substrates to make energy, ATP, but different ways I'm going to use nutrition. So there's clinical value for us as well as value in other settings like the occupational setting. The idea of this and the idea of mental fatigue starts with starts from this fellow who was a researcher in the United Kingdom. His name is Eric Newsham. He was one of exercise science's big idea guys. And he was actually a physician, and he proposed the idea of central fatigue during exercise. And even though the schematic on the right is not so great, basically the premise is when you exercise for a long period of time, eventually you mobilize fat to create ATP. And when you mobilize fat, one of the things that's often an outcome of that is you end up displacing tryptophan from the molecule that carries it in the blood, which is albumin. Okay, and when there's more tryptophan in the vascular space, then more tryptophan can cross the blood-brain barrier and can be used to make serotonin. And so in the United States, we often associate the idea of having fatigue after having a Thanksgiving meal is because you ate something that had a lot of tryptophan in turkey. So that's the original premise. Professor Meeson and I had our first discussion around this, and one of the things we agreed upon is that even though we're starting with the neurotransmitter serotonin, we're probably not going to end up with the neurotransmitter serotonin. And if you look at the lab over here at Blitz right now, they're doing a lot of work about neurotransmission and mental fatigue, but they're focusing more on dopamine and noradrenaline or norepinephrine. Well, as we think about supplements, the thing that we need to understand is they can have a sensory effect. And here are 3 supplements. We're going to talk about the middle one, glucose, today, because that's the main molecule in carbohydrate, obviously. But on the right, we're currently doing work with coffee. And the important thing to understand about coffee is there are a billion different molecules in coffee that can create a sensory stimulus. And so we are interested in how it's roasted. We're interested in what the concentration is, all those type of things. We're going to focus on glucose today. On the far left, I think this is where, and I think I've shared this with somebody, I think this is where we're going to land in the long run. This is quinine, and quinine is a noxious stimuli. So if you put quinine in your mouth and rinse your mouth with it, you say, oh, that's a bad taste, right? And I think it's the noxious stimuli and the response we could have to noxious stimuli may be where we end up in the long run. But that's my idea. So let's talk a little bit about glucose. In this figure, this shows a relationship between the receptors in the oral cavity, the mouth, which I don't think I can do very well with my pointer here. Try it again. Oops. Now my thing's working. Okay, that didn't do that again. Okay, so we see receptors in the mouth and the oral cavity, and they send direct sensory information to the brain, which is then summated in the sensory cortex. And the sensory cortex talks to the motor cortex because they are millimeters away from each other, and precipitates the increase in motor function. And that's the idea. One of the fascinating things I learned from my colleague at NC State is that we have sensory receptors for glucose, sensory receptors, not just in the mouth. We have sensory receptors in the esophagus, in the stomach, and in the duodenum of the small intestine. So we can sense glucose in all of those places. And it makes sense from sort of an energy balance standpoint that when I sense I've got carbohydrate, I've got glucose that I can make ATP out of, well, guess what? I'm going to move around more, right? And so that's the premise that we're looking at more today. Here is just a big slide that talks about all of the previous studies that examined the relationship between rinsing your mouth out with carbohydrate, and in this case, all these studies are physical performance. You can't see it very well, but if you looked on the far right, you would see quite a variety of improvements in performance. There are some that are as small as 1%, but there's one study that has a 12% improvement in performance. And this is riding a bike at 60% of VO2 max, which is hard but not super hard for an hour. So they were able to improve their performance by 12%. This idea of using sensory information in the mouth has been present in sports for as long as we can remember. There's a famous American baseball player, Babe Ruth, who did this, but he did it with whiskey. He would put whiskey in his mouth, swish it around, and spit it out, and then go up to bat in baseball. And so, and there are many circumstances that we can find examples of this. So this idea that there's an improvement in human performance, physical performance, as a result of carbohydrate mouth rinsing has been well established. This is a reference of a review paper by Daniel Pert about this. So we know that there's this relationship. We can improve performance to some degree with carbohydrate mouth rinsing. Usually, it's aerobic performance, things like time trials and things like that we can have an impact on. But this relationship has not been examined as far as we know with the presence of mental fatigue. So the purpose of this study that I'm presenting today was to determine, first, if mental fatigue causes a change in corticomotor excitability, which is our measure of physical performance in this study, and then to determine if a carbohydrate mouth rinse can combat those impacts of mental fatigue on this outcome measure. The people in this study, it's a little bit different than what was on the abstract. We have 15 college-age males, nine female and 6 male. All these other measures of height and age and weight and body mass index are all pretty typical for that age group. And then here we have our experimental protocol. Our experimental protocol started off with determination of the corticomotor excitability on the far left here, the MEP measurement, motor evoked potential. We'll talk about that. And then subjects completed 6 bouts of the Stroop color word test, and in between each bout, they completed a mouth rinse. And that mouth rinse consisted of 25 milliliters of a fluid that was either placebo or it was 6% carbohydrate. So things to remember here is that for each of these Stroop color word tests, there were over 300 trials in each one of those, and we're going to talk about the perception of mental fatigue. The 2 mouth rinses that they used were indistinguishable in terms of taste. So our folks at NC State were able to create a mouth rinse that tasted the same to everybody, but some had carbohydrate in it and some didn't. So we measured corticomotor excitability by using a device called a transcranial magnetic stimulator. and we looked at its function on a muscle in the hand, the first dorsal interosseous. In the bottom right, we have an image of a hand being instrumented with EEG measurements, electroactivity measurements, to look at the activity in the FDI. And on the left, we have this is the chair the person would essentially recline in. They would put their head back, and this device here, which is like in a figure 8, is the stimulator, the transcranial magnetic stimulator. And we can move that around. You would be fascinated by it. We can move it around very precisely and facilitate different motor functions in the body. And what I mean precisely, we can move it 5 millimeters and get a change in motor response. And so what the first thing we do is the subject comes in and sits in the chair, and then the researcher positions the cone where they think it needs to be to precipitate the greatest contraction in the FDI, or facilitate that contraction of that muscle. And then they explore a little bit in each direction until they can identify which location has the greatest impact on motor function. Well, how do we ensure that we're actually going back to the same place over and over again? We use this device. This is from MagStim. This is from their website. It's an ANT Neurovisor 2, and it allows us to place the device in the same place based on markers that are on the stimulator. So we're ensuring that we're stimulating the brain in the same place, and it works very well. So what are we trying to measure? We're trying to measure. The slide talks about the science of TMS. We're trying to measure the motor evoked potential, which is shown in this graph on this right. On the right here, we've got some baseline EMG measurement, and then you can see when we stimulate that FDI, we see a big deflection up and down, which shows that we've effectively stimulated that portion of the brain that's responsible for initiating contraction of the FDI. And really what we're measuring when we're looking at corticomotor excitability is how big that deflection is, okay? So the bigger that deflection, the bigger the motor evoked potential is that we're trying to precipitate. This is how we measured the perception of mental fatigue. We asked the subjects to make a mark before they completed the task and at the end of the task of their fatigue, and they took a pen and they would mark on this line, and it's a 100 millimeter line, so we can use that to our value, as we'll see in a second, to indicate where their perception of fatigue is. And they always received a blank page like this, so they can't necessarily, they might be able to remember, they can't really reference where their perception of fatigue was in the previous measurement. So let's talk about, let's talk about the perception of mental fatigue. When we look at perceived mental fatigue after the several Stroop color word tests, we can see that the placebo group had a 30 millimeter increase in the perception of mental fatigue. In comparison, the carbohydrate group had right around a 20 millimeter increase in the perception of mental fatigue. So the perception of mental fatigue was worse in the placebo group than it was in the carbohydrate group. So the carbohydrate treatment was effective at mitigating the perception of mental fatigue. And this slide represents the impact on corticomotor excitability. We can see when we look at the placebo group, which is the solid bars, they had a pretty significant reduction in the size of the MEP after the Stroop color word test, after they were mentally fatigued. And for the carbohydrate group, theirs went down as well, but it wasn't a statistical difference. It just went down a little bit. Well, how big of a difference are we talking about? This image shows that difference. We can see the placebo group, their motor evoked potential went down just under 20%, about 18% on average. The individual gray lines represent each individual subject, and then the black line represents the average. I should have mentioned that earlier. Whereas the average change in motor evoked potential in the carbohydrate group was near zero. Right? It went down a little bit, but it is not as great as the decrease in motor evoked potential that we saw in the placebo situation. Okay, so we're able to mitigate the impact on perception of mental fatigue. We're able to reduce the impact of mental fatigue on the ability of our motor systems to function. What about cognitive function? The ability of the brain to do the things we're asking it to do. And this is data from the 6 bouts of the Stroop color word test. And there's things that we can see that seem pretty obvious, that how fast we're able to respond to the congruent reaction time, the congruent stimuli, which you'll understand that if you understand the Stroop test, and the length of time, how fast it took us to respond to the incongruent stimuli also improved, but there was never a difference between the two treatments. The cognitive function was the same between both the placebo and the carbohydrate environments. This is very prevalent. We can look at the accuracy. The accuracy is incredibly high in both groups, well above 90%, and it didn't change over the period of time of doing that Stroop color word test. So what are our conclusions? Our conclusions are an increased perception of mental fatigue is associated with a reduction in corticomotor excitability. So if a person feels more mentally fatigued, their ability of them to initiate a response in their motor system is reduced. And a carbohydrate mouth rinse does appear to attenuate the negative impact of a mental fatiguing task. But it did not impact their performance of cognitive function. So this suggests that a carbohydrate mouth rinse may be valuable to reduce the impact of mental fatigue on motor function. And I guess my suggestion is are these type of strategies that we may need to consider applying when we're going to ask people to use exoskeletons and robotics in an industrial setting on a large scale to help maintain their performance? And as I will suggest or remind you, I think I said earlier, is the percentage of carbohydrate in the mouth rinse we used is the same percentage of carbohydrate that's in just about any sport drink in the world. That's 6%. It's Gatorade, it's Powerade. Almost any sport drink in the world has about the same, that has carbohydrate in it, has the same percentage of carbohydrate, which was, I don't know if anybody cares about this, that percentage was a lucky guess by a physician that was working with the University of Florida football team. So thank you for your time. I'm happy to entertain any questions you have. Or we can move on to the next person. Okay. Thank you. So, any questions? Okay.
Yeah, thank you for a very interesting talk. I would like to follow up on the last slide, where you seem to distinguish between the perception of mental fatigue and mental fatigue. Can you elaborate on that? Because what do you show? Do you show the decrease in perception of mental fatigue, or how do you distinguish between the two?
That's I think that's a fabulous question. I think the only thing that we can accurately comment on is the perception of mental fatigue, because perception is what we use to determine whether or not the person thinks they're mentally fatigued, right? And but we didn't have any documented evidence from the cognitive function test that their mental fatigue actually resulted in a decrement in cognitive performance. That's a great question, and you know what? That question, as you suggested, that is in a sport or a physical treatment environment. We face that all the time of trying to figure out, is this somebody's perception or are they really having a physiologic problem that's causing the outcome?
Following up on this, it could well be that the perception of mental fatigue makes you try less at things you would try otherwise. So it does have some reality. It's not just placebo.
Yeah, that's a really good question. I was just talking to a PhD student this morning, and who is establishing a protocol where they're looking at the impact of mental fatigue on both physical performance and cognitive function. And when it came to the physical performance test, one of the things I was curious about is well, are you going to ask them, do they feel like they're ready to exercise, right? Or is this perception of whether or not I feel like I'm ready to exercise, is that something that's precipitated by the condition of mental fatigue, or is it a perception that's being impacted by many other things? For example, you know, we exist in this world in a circadian rhythm. All of us exercise, we probably exercise at the same time of day, almost every day. And so we may perceive that I'm more able to exercise at this time of day where I do my physical training, and that may be influenced by how I've impacted how my circadian rhythm is responding to my day. I think that's an excellent question. And I guess maybe my question back would be, in the end, is that going to matter to us?
Well, the thing is, if you think you're not ready to do something, you're not going to even try to do something, right? So that's
right. Oh yes, right. Okay, but if I have a mouth rinse for you, whatever it is, if it's quinine, if it's carbohydrate, and I impact whether or not you think you can do something, well, maybe I'm doing my job.
I'm going to try your mouth rinse.
Okay.
Well, I have a small question associated with the previous one. That is, on the one hand, the perception, of course, is what might make you do something, but on the other hand, mental fatigue is what can make you do mistakes and get injured. So is there some kind of connection with that? Because if I think, for instance, in work environment, that's the main thing. I can care a lot about how people feel, but it's much more important that they don't get injured.
I agree. It's much more important that they don't get injured. My response, my brain was going in two different directions to your question. I guess maybe the question is the perception of mental fatigue, is it equal to?
Well, we know that sometimes a wrong perception, it's actually dangerous,
Right,
because it does not show you which is your real limit.
right. So I guess maybe your argument would be, which I wouldn't disagree with, is okay, if we're going to analyze this, look at the effect of this thing called mental fatigue, do we need to precipitate mental fatigue to the point where we're seeing a decrement in whatever type of performance we think is important, whether it's cognitive performance or it's a fine motor control effort or something like that? And I would agree that that's something that our profession has been struggling with to determine consistency around. Is mental fatigue the perception of it? I feel tired, or does there need to be a measurable outcome in a different way? And I think we would feel better about our conclusions or recommendations if we were able to look at the second circumstance a lot more precisely.
Thank you.
Thanks for the presentation. I was wondering, is there already someone interested or some ideas to put it to some form of use case, or what would your idea be of a first use case?
So I think that the group here at VUB they're already positioned to look at questions like this in robotics and or exoskeletons in a human environment. So I think they're already thinking about these circumstances because of their expansive work with mental fatigue or the neurochemical events that happen during exercise. So I guess I would argue that they're the best positioned group in the world to do this, and also because they're so closely associated with this BrIAS effort. Thank you all for listening to me and all your great questions. I appreciate it.
Okay. Yeah, thanks again, Stephen Bailey. Okay, before we move on to our next speaker, I will do a little advertisement on behalf of BrIAS. There will be the second forum coming up on the 29th of March, and the topic will be sustainable robotics technologies. And we have a full day with a lot of speakers, very interesting topics, and also a little discussion on batteries and energy use. So please do join us on the event if you can do it live or online. I think there's like an event page where you can apply and register for it. Okay, thanks. So for the second speaker, it will be Franziska Kirstein. Okay. Oh, sorry. We'll have a quick break before we do that. I'm sorry. I'm not going to hold you off your coffees and cookies. So yeah, short break, and then we'll move on to Franziska. Sorry. Okay, welcome back to the seminar after a short break. We will now have our second speaker, Franziska Kirstein, and she's coming from Singapore / Denmark. Her company, BlueOcean Robotics, resides in Denmark, but she's also working from Singapore. And I think she got involved into robotics due to her master's into human-robot interaction. And ever since she plunged into it from the more business side of point of view from BlueOcean Robotics, but she's also now helping in the EU Robotics Topics Group Sustainable Robotics, and she will now give a talk about the combination of the business side of robotics and also the sustainability aspect in this topic or subject. Welcome, Franziska. Give it up. The floor is yours.
Thank you. Okay, let me get my slides on. Yes, thanks. That was a quite proper introduction. I'm gonna actually talk today about some work that I've been doing since I started at BlueOcean Robotics in 2014 until maybe 2020, 21. That is the design and development and manufacturing that has happened afterwards, of course, of these two robots that you can see on the slides with sustainability in mind. And right now we're in the commercialization phase of those robots, but back then we started with nothing than just an idea of what problem we wanted to solve. I work at BlueOcean Robotics. We have right now 3 robots in our portfolio, and today I'm going to just focus on the 2 of them. You'll hear more about that just in a bit. Yeah, BlueOcean Robotics is located in Odense. We are actually in Odense quite a lot of robotic startups. It has been initiated by Odense Robotics. You might know Odense also and Odense Robotics from the European Robotics Forum last year. It's quite an ecosystem concerning robotics where you can exchange ideas, exchange expertise on how to start up your own robotics company, and I think it was mostly initiated through the 2 probably you know them, 2 companies, Universal Robots, Mobile Industrial Robots, that we have there that drive the ecosystem also. And of course, Odense is the hotspot. It's companies from all over Denmark that are joining, and you can see it's around 300 across the country, but I think we're slightly over 100 robotic startups in Odense. So really good location to come up with a company. Since BlueOcean Robotics was founded in 2013, we have been interested in making robots for humans. So that fits very nicely with the Sustainable Development Goals, talking about sustainability today as well. And yeah, we are focusing on increasing quality of life for people through our robots. So that is really the focus on when we go into a project. We want to help humans with the robots in their everyday life. These 2 robots I'm going to talk about today. The first one is the UVD robot, that's short for UV disinfection robot, and the other one is the PTR robot, patient transfer rehabilitation robot. And the UVD robot, we started developing it in 2014. There was no concept at all, just knowledge that we wanted to reduce hospital-acquired infections. That was our goal. So you can see the normal process on the top without the robot. You do the manual cleaning, and not all surfaces are sufficiently disinfected. And with the UVD robot, does it work, the pointer? Yeah, with the UVD robot here, you have the manual cleaning, and on top you have the robot afterwards that comes in, that goes around the room and disinfects the room. And you might not know it, UVC light, it's killing bacteria, and that's why we use it for that robot. It is an environmentally friendly method compared to chemicals, for example. UVC light is not naturally found on Earth. It's blocked by the ozone layer, and it can only be found artificially. And that's why bacteria are not used to it and get killed if they are exposed to it. Now, UVC light has in the US been on the market for quite some time. There are manual solutions that you can see on the left. You need to put them in the room on one spot. Then you start them. You, of course, leave the room because it's also harmful for humans. And then they start disinfecting from that one spot. You then need to go in again, move the manual solution to another spot, start it again, and go out. So it can take up to 50 minutes actually to disinfect a room with a manual solution, and that's why we thought it would be quite clever to put that UVC tower on an autonomous robot. And that is what you can see on the right. So you can see that you put the robot in the room. Actually, you just open the door for it and it goes in. And then you start it. You close the door, start it on the tablet outside the room. So it's also quite safe. And the robot starts up, disinfecting inside the room and moves autonomously from spot to spot. And like that, reducing shadows, I think, reducing shadows and actually covering a larger area in the room. And just so you get an impression, it is a bit of a commercial video, but I think you get a good impression of how the robot is moving and what the size of the robot is compared to the room and what you can do with it. So this is filmed with test tubes, so no people were harmed in the process. And as I said, 50 minutes for a manual solution. You could see 10 minutes for the robot, and in that 10 minutes, it has gotten through the room and disinfected the room properly. The second robot I'm going to talk about today is the PTR robot, and it's designed to help patients with temporary or permanent reduced mobility skills. You can see it can move a patient from the bed to a wheelchair. It can help people who have fallen on the floor, but it can also help with rehabilitation exercises. And actually, when we started developing both of these robots, there were manual solutions, but there were no autonomous competitors in the market. So mostly we tried to compare the manual lifting and manual disinfection versus the robot that we have. And when you look at manual lifting, it's quite exhausting for the healthcare professionals. You can also see there is 2 people lifting one patient, or even 4 for heavier patients, and they need to communicate, and that's quite exhausting for patients. And if you look at the, especially the manual solutions here in the bottom and top right, they don't feel very secure when you're being lifted in those lifting devices. You can already see it. It doesn't feel like you're really lifted properly and secured in it. And that's something we wanted to change. So on the right, you can see with the patient lifting rehabilitation robot, there's actually only one person. So it's possible to lift a patient with just one person, even though according to regulations, I think in most EU countries, I don't know about the rest of the world, you need to be minimum 2 people to lift a patient, just to have the patient securely lifted. But with the robot, I've tried it. It's not a problem to lift 1 person. And also there are a lot of new ways that you can come up with to lift a patient, actually. So you can be quite creative on how you place it. For example, having the 2 beds here next to each other and just moving 1 patient from 1 bed to the other. That's not possible with the other lifting devices. So it's much more comfortable. It is much less exhausting for the healthcare professional, but it also gives the patient much more dignity while they are being transferred. And that was something that we were aiming at. So I've mentioned it in the panel this week already. There are, of course, a few autonomous solutions. Here you see a robot from Japan that is also designed to lift. It has a more animal, humanoid form, and that is something that we actually wanted to avoid in our design, because we wanted to, in a subtle way, support the interaction between the healthcare professional and the patient. And here you can see that the robot is for the Japanese robot. The robot is more in the center, and the healthcare professional is more in the back, watching or maybe adjusting, but it's here it's the interaction between the patient and the robot that is in focus. And of course, that really depends on what you want to develop, and that depends on the situation and the application. But for us, it was important that the robot is more a tool that is supporting the actual interaction with the patient and the healthcare professional to make their lives easier. And also a little video here, just so you can see, because should I mute it? Okay. Can you hear it? Okay.
Using the panel buttons, the PTR robot can expand and collapse to fit hospital and nursing home needs. The sling bar is hand controlled for maximum ease of use when attending the patient. It can be moved up and down, to the right and left, for the benefit of the caregiver. With this robot, you can transfer patients up to 250 kilos or 550 pounds from bed to wheelchair, bed to bed, bed to toilet or bath, turn patients in bed, and much more with the use of only 1 caregiver. Because of the mobility, fallen patients can be assisted anywhere as long as the entrance is minimum 80 centimeters or 31 inches in width, almost every door. With its rehabilitation features, it is able to support the rehabilitation of patients, ranging from the early mobilization to various balance and gait exercises. The PTR robot takes transfer to the next level.
And I think the video really highlighted that it can solve a lot of issues that we identified during our user research, and especially that you have a lot of equipment for just one purpose that the robot can combine in one solution. And it might look quite complicated and quite big, but if you once operated it, it's quite intuitive. Now, before we started developing the robots, we wanted to make a framework, come up with a framework on how we can support long-term sustainable implementation of the robots in everyday situations. And for that, of course, that it's important for us, because we want to make sure our robots are being used. They are scaled up in the end. They are getting into the hospitals, and of course we can sell a few more of them if users are happy. So of course that's an important point. But the important point is also that we really develop something that makes sense for the end user. And yeah, I'm just going to tell a little bit more about how we did that. This is not based on any literature. It's based on our experiences, that the team that worked back then together put together, and I think we had background from engineering, designers, roboticists, me looking at the human-robot interaction, and project development. So all that got into this framework. And today I'm going to talk about point 3, the Robi design and the Robi develop of these 2 robots. So the Robi design, that's a robot business design, we call it, is for us a partnership program where we co-create a robot concept and a business plan. And it aims to look at what is the task at hand, what is the challenge, do we actually need a robotic solution in this scenario, does that make sense, and would this be a good business for us to go into? And then eventually put that into a robot concept and also a business plan together with all stakeholders. So we have certain stages that we go through, and at each stage we check whether it still makes sense to continue. And the first one is, of course, the agreement and the project plan. And these projects, they started as public-private partnership projects, which I think is quite a good basis for a successful robot design, because you can take a little bit more time to focus on the user needs. You have a financial setup, and you have the commitment of the end users, because especially working in hospitals, that can be quite a challenge, because everyone is so busy that even though they are excited about developing a robot and they know it's going to help them, they have other things to do. And for the UVD robot, like I said, the goal was with the hospital in Odense to reduce hospital-acquired infections. And for the BTR robot, to support their healthcare professionals. And then also, because they were building a new hospital, it has actually just opened, and they wanted to increase the robotic solutions there and also look at how they should implement robots in the hospital, but also reduce, like I said, all the equipment that they had into one solution. So the robot was supposed to, or is supposed to, handle 90% of the patient transfers and rehabilitations for 785 beds. And the rest, 10%, these are pre-installed ceiling lifts, because they are really intuitive, but they are not very flexible, because they are installed in the room and the patients can only be moved inside the room with those ceiling lifts. So what we did was we went quite a few times out, did field research, did workshops with the end users. Here on top, you could see I followed the cleaning professional quite some days, looked at her routine, looked at what she's doing before, what she's doing after, how much time she's spending in each room. We checked how big the hallways are, how many things are standing in the hallway, is it easy for the robot to go through, how big can the robot maximum be. And specifically with the PTR robot, we tested a lot of the solutions that they had there. So that was really a full day with healthcare professionals, with the hospital management, with patient representatives, and going around and testing all these solutions. Something that was very helpful for us is the job to be done, because there has been a lot of discussions throughout. You could see, I think, in the start, a project like this takes 4 to 6 months just to come up with a proper concept. And when you have so many people from different disciplines, there are a lot of discussions involved. So we really tried to be precise in the way we were working and agreeing on a lot of steps on the way. So the job to be done is very helpful to target the project scope and the focus, and usually formulated with verb-object context. And for the UVD robot, that was disinfecting bacteria on surfaces in patient rooms and adjacent bathrooms. And the PTR robot more had 2 of them support the patient during transfer happening inside and outside of bed, and lift, transfer, and lower patients who are not able to stand to destination. Yeah, and after all the field research, or actually while we did that, we had the data collection and the analysis. Show an example of that in a bit. We also did a lot of desktop research afterwards, writing the current scenarios, so really in detail, what are the cleaning personnel and healthcare professionals doing these days? How does their day look like? How does a specific patient lift look like in different scenarios? So it was quite a long document to be able to analyze everything and bring everyone on the same page, and also persona of everyone who is involved. And the desktop research was mostly also reviewing the guidelines and regulations, because both for cleaning and patient lifting, there are quite some regulations and guidelines involved. Like I said, minimum 2 people for lifting a patient in a hospital, which is a little bit also a challenge, because our business case was also based on that you save a lot of time, because you can actually do the lifting with just 1 person. And here you can see in the picture, you can see an example of that was just, of course, we had a lot of text, but we also tried to make it very simple for those involved who didn't have time to read everything, on how could a workflow look like with the robot involved, and to see whether that would fit with potentially the cleaning personnel, which we thought would probably operate the robot, but we didn't know at that point. Yeah, the data collection, you can see an example here. I don't think you can see the details, but whenever we did user research, field studies, also desktop research, we added the relevant fragments that you can see on the left to this document. It was a huge Excel sheet. Of course, noted where the source coming from. Here you just see examples from questionnaires. Then what the user need is, and we divided that here. This is from the PTR robot into categories. So, of course, working with patients, it should work in silence. So the category there is noise. Then there's a lot of user needs on space saving, and we tracked all of those and converted them into small guidelines, and afterwards also prioritized them. Yeah, and a little bit about the business side. I tried not to put too many slides about the business aspect, so I'll also hop over the business development stage here. But having the business case set was very important for us in the beginning, because it meant that the robot makes sense for the customer, and we'll be able to actually sell it eventually, because no one has any benefits if a robot is developed, but it's not a good business case in the end and doesn't get out on the market. So that's something we focused on, and actually all the user research we did in the beginning helped us to come up with these parameters here. These are just a few examples, and also to collect data on those parameters, so we could come up with a business case. And at the end of this, we had the concept, and then we had the business case, and we could say, okay, this concept, it makes sense for both of us. We'll be able to make a business out of this. Also existing solutions. I mentioned there were not a lot of autonomous solutions, but it was also important to analyze all the existing solutions. And here you can see example again from the PTR robot. We divided it up into the categories of the transfer, and then evaluated how useful are these tools during the lifting, and where do we want to be better in that. And of course the healthcare professionals helped us here to evaluate it. And once that is all done and we collected all the material and everyone was updated on the material as well, we had quite some brainstorming sessions that also ended up in a lot of discussions in the end. But we used, for example, mock-ups. You can see here that was for the disinfection robot. The red aspects are hotspots that the robot was supposed to disinfect. Here you can see some inspirational images when we had some brainstorm on how the robot should look like. And actually, these were some of the first concepts that came up, and you can see they look quite differently from the robots that we have right now. So for the UVD robot, initially, the idea was also to have, so it has arms, so it can actually target hotspots. We found out that it's not necessary because UVC light is so intense that you don't need to actually target. It catches the hotspots anyways. And here, actually on the right, you can see the small robot on the wall. That was the first idea of the PTR robot because space was for us an issue. So we said, okay, you can make a robot that is big and that can transport a patient, but then you can make it small and you can put it on a docking station in the room. But we soon figured out that that's technically impossible. So once we have good concepts and we collect the best concepts and again, decision-making, trying to facilitate the discussion, but in the end actually making a decision that we can prove has been validated by most of the people. And that's why we actually came up with parameters and then just voted. All stakeholders voted on what they think is the best solution that we should go ahead with. And once the concept and the business plan has been set, we go into the Robi develop. Now, I won't go into detail because that can take up to 3-4 years. But it is, again, we're a collaboration between the technical team and the business development team and a lot of testing being done. So you can see testing on the left in the technical wheel. It is very important for us that we have a lot of interaction with the users where they give us feedback, where we have user testing, and that takes a while. So that is quite an effort, but I think it's worth it in the end. So just an example of the evolution here from the prototype, and this was the first. It was a little bit more squarey than we had expected when we had the design. I think you can see it maybe not on the next. I have a slide where you can see that it was supposed to be very smooth, but we couldn't get all the hardware in it and have it smooth at the same time. I think now it looks much nicer, but the first prototype still worked very well. And yeah, one more video. Let's see. And this video doesn't have any sound. You can see that's the that's one of the final prototypes at the end of Robi Develop. And why I put this video here is it really nicely shows how we got together. So she's a healthcare professional, and there was user and patient representatives, and the hospital management was there, and our developers and our developer, you can see the mechanical engineer also somewhere. They were all there, tested it, talked to. Of course, very difficult because we are a very international team and the healthcare professionals prefer to speak in Danish. So there are also communication problems. But for example, he's from Denmark, so translation, he could translate. But I think that's a very nice example of such final stages testing also that we had together with the end users that are so important because you always learn a lot from these sessions. Yep, plays again. Yeah, so this is the slide, the first one on the left. That's what we imagined it could look like, but the first prototype didn't look like that, obviously. But I think we're getting close now. This is how it looks like now. So it took a while. Actually, the 3.5 years, that's just from concept to the prototype in the middle. And to get to this stage took even longer. And when you see that this was the first prototype we had in the basement of our small company back then, it took a long time and a lot of technical discussions in the development phase also to come up with the prototype that works and is safe to use also for the user. Yeah, and after that, it gets interesting for me again. So we hopped over the whole development. That was a lot of technical challenges. I wasn't very much involved in that. Once we have the first prototype, we introduce it to the hospital. We leave it there. So we had a workshop with the caregivers. To collect their input, to collect feedback, to see how will it work in the real world. We also noticed some technical issues that we could fix right away, and we also noticed some that we could get back to develop on. And this workshop was also to start up and to teach all the healthcare professionals who were supposed to use the robot, to introduce them to the robot and teach them how to use the robot. So you can see there was 98 participants. It took a few days, but it was really good sessions to get them introduced to it. And we also made use of that chance to collect data on the usability. And here we used the system usability scale because it's just a very straightforward questionnaire, and we can use it for all our robots and compare. And we got, of course, a lot of good feedback, and we were hoping for that because we spent so much effort including the user and designing something that is user-friendly for them. But still, of course, also we got some comments that, oh, I'm a little bit afraid. I don't think I would be able to do this without a technical person. And there are always, of course, people need time to get to know the robot. If I'm using a Mac, if I would now change to a computer that has Windows, it would take me quite a while to get adjusted to that. And even though I know it might be worth it, I get benefits. The healthcare professionals, they knew that the robot will help them, that it will be easier for them to transport patients, but they don't have the time to look into it, to get familiar with it, because I think right now we are already at a stage in healthcare where we are lacking so much personnel that it will be very challenging. That it is very challenging to introduce robots, because introducing robots to a hospital takes time, and hospitals, personnel in hospitals right now, they don't have time anymore, and that's a little bit of an issue and something that that is also a challenge for us. So we had, so this was just also a quote from one of the healthcare professionals, that we only use equipment that we feel very comfortable with. You never know how the situation with the patient might develop or even escalate, and I have no time to practice with the robot because I need to attend to my patients. So that is the challenge, that even though we developed a really user-friendly robot, that was a challenge once it got to the hospital. Yeah, and this is just a video to show, also doesn't have sound, to show that the robot fits through a door. It's but in a different way that you might think. You would probably usually transport a patient straight forward to the door, and now you're shifting. And there are a lot of situations where you would also not lift a patient like this on top of a bed. You would come from the right. So there are a lot of situations where the healthcare professionals need to rethink. They need to rethink the way they are transferring patients. And they can be really creative with this robot because it gives a lot of more opportunities. But they need to have the time and the creativity in their work to be able to do that. And that was very difficult for them because they didn't really have the time. Yeah. So how we tried to support it was we had our specialist. This is Britta. She is physiotherapist by background also and was our expert for the robot. I think she was there weekly after we introduced the robots, and she was always in contact with the healthcare professionals, checking in, are you using the robot? Why are you not using the robot? Should we maybe go through it again? Should I show you again? She also came up with new scenarios and a lot of videos on helping the healthcare professionals. So this is something that you couldn't do with a manual solution, lifting a patient in the bathroom who has been falling in the bathroom. So she came up with all these scenarios and videos and instructions to help the healthcare professionals in their work. And then she also educated super users, we call them. So people who are very open-minded, they are really interested, they have the energy, even though they might not have the time, they have the energy to learn something new, and they can be there for their colleagues, they can educate their colleagues, they can answer questions, they can be called if their colleagues have issues. And that worked out quite nicely and helped. And this is something different, switching now to having the robot working in the environment. During COVID, there were a lot of new applications that came up for the UVD robot. It was specifically designed, and you could see that we had the scope, we had the stakeholders, and it was really designed to work in a hospital, to disinfect patient rooms. And during COVID, of course, everyone wanted to disinfect their places. So the robot got out to supermarkets, to airports, to prison, to schools. This is a hotel also. But the environment is different, the people are different, the end users are different, their workflows are different. So you really need to put a lot of effort into taking a robot from one application and transferring it to the other. You really need to be careful about that, and probably go through the whole first process that I introduced earlier, and analyze that again. I think now I have talked a little bit about the social and economic dimension of sustainability. What we didn't include really back then and weren't aware of is the environmental domain. That was something that more came up afterwards, and probably also we wouldn't have had the resources to actually think about which materials should we use when we develop the robot, or because it was difficult enough to, technically difficult to build the robot, to find the parts, to make it fit in a small version so that it can fit in a hospital room. But now slowly we are looking into how we can transition into more sustainable manufacturing of our robots. Of course, there we looked at the low-hanging fruits, transitioning to green energy. Waste sorting was not really a thing in our company. Now it is. Refurbishment of robots, that is actually something that has been really good for us, because we can take back the robots and sell them as refurbished, and that has been appreciated also by customers. I know in some other robotic applications, it's not. But a robot that is working, that is disinfecting the room properly, is still good to go. Of course, we are also looking at regional centers, so we don't need to ship that much. And we have started to do life cycle analysis for our robots, specifically for the telepresence robot that I didn't talk about that much. So trying to put effort here and there as much as possible. And why we're doing this is, of course, because we're all nice people and we want to have the best for our planet, but also because our customers require it more and more. So we have also big customers who want to have the robot in their office space or in hospitals, in big hospitals, and they require to know where the parts come from, how the robot has been made. It can also be a financial benefit, like the recycling robots that we could resell them. It was also for us something to attract investors in the end, to have a more sustainability agenda. And how we did it was partly internal budgets, but we also used student projects, for example, for the for the life cycle analysis. And in Denmark, there is a lot of national funding that you can use, not for robotics, but just helping SMEs to become more green. Yep. Next steps, that was for us modularizing our robots to optimize the transportation, because they are very big. And also the flight cases, they are very big. They take a lot of material. And actually, we had the ISO 14001 certification on the list. I think 2 weeks ago we got it. So that's a really good achievement also for us, and also an achievement internally, because it's not only now, it's also in the future. We need to keep looking at it. So it's a constant reminder that we need to keep environmental aspects in mind. Yeah, those were just a few ideas, and of course, all the things I presented today, especially the Robi design and develop, that was not only me, that was a whole team of people. I hope I have mentioned most of them here. Yeah, I'm looking forward to your questions. And of course, here you can see me playing around with the PTR robot, trying to look at, so what can we do with it in the future? Right now it's operated by humans, but what if we put AI in there? Can we enhance rehabilitation? How can we make rehabilitation more interesting? So that's another whole topic that is very interesting to look at, because there's a lot of potential, especially in the PTR robot, on what you can do with it in the future. Yeah.
Okay, thank you very much. Very nice talk.
Sure.
Any questions?
Hi. Very nice talk. I think you get this question a lot, but what's the impact of the introduction of the robot for healthcare professionals? Because you gave that quote, that was very nice, but you also mentioned that it takes fewer people to lift someone. Yeah. So what are the others doing? Right, so what will that's the question.
Yeah.
Wouldn't it be better, because to explain to a healthcare professional how to operate a robot is not necessarily straightforward, wouldn't it be better to have a specialized operator in every hospital that is only dedicated to this robot, so you don't have this conflict with healthcare professionals, making them feel they should learn how to operate a robot? What do you think?
Yes. So the first question, not sure whether that hint at the robot is taking the job of the other three, sure. But well, you might, and I mentioned that you might know that we're lacking healthcare professions, we're lacking personnel in the hospitals. So I'm pretty sure there's something to do for the other three, and they're super happy that they don't need to do it. And actually right now, even though there's the guideline that minimum two people should be lifting a patient, that's not always the case, because you might not be able to find someone that quickly to actually help you lifting a patient. So it is for them more a support, so they can focus on other more qualitative tasks, hopefully, and actually give the patients the care that they need at that moment. Because I've heard stories about patients lying on the floor for a long time just because the equipment wasn't there or the personnel wasn't there. So that's more the situation than actually the people worrying about their jobs in this specific area. Yeah. And what was the second question? Oh yeah, having the operator. I think it would be a lot to organize if you have one. So you imagine that you have one person that can be called in order to lift a patient. Yeah. I think it's the same situation. I think it would take too much time, and it is really not a difficult device to learn. So you can easily take it like any other device and work with it. But maybe having someone there who can come and help or support, and that was the idea of the super user, is time-wise a better solution. Because I know you're nodding. In a hospital, everyone kind of needs to do all the tasks, so it doesn't make sense to have just one person doing something. Yeah.
Thank you for your presentation. As somebody who I educate people who are going to be physical therapists in the United States or physiotherapists in Europe, from our knowledge, our experience, that the thing that takes the most people and is the most dangerous is proper placement of the patient in the sling device.
Yes. Yeah.
And so I'm curious, do you have any strategies to facilitate that in this population you're trying to serve?
That is a really good question. So what we did with the super users and Britta, who I mentioned in the hospital, she was really educating people on this matter, also on how to do it and how to improve the lifting. So it was not only about the robot; it was also about the education in general. But about the sling, we can't do that much about it. We've had, I think, even 2 projects. So in the beginning, when we looked at the robot and developed the robot, we wanted to have a new project just to design a more robot sling that can support the patient better. But it's too complicated. And the hospitals, they have their equipment, and they have the equipment that they have bought, and they rebuy that. And it was obvious for us that it's going to take a long time, and it's going to be very difficult to get into that, to design a new sling and to have that marketed together with the robot or on its own. So I think it's definitely a need, but it would take a long time. So that's why we didn't get into it.
Great, thank you. A follow-up question. Yeah. My experience of seeing new equipment being applied in the hospital, oftentimes the value of that equipment is not based on what it does and if it does it well and does it not take up space, but how it impacts other things that professionals are required to do. And I'm curious, is that part of your evaluatory process, and do you have a sense of those type of outcomes?
How it?
So, like,
give an example.
Yeah. So, say for example,
yeah.
Nursing may say, "Well, okay, this is great. It can pick people up. That's great.
Yeah.
But you know what? This is a barrier to me to go in and take the patient's blood pressure, so I'm not going to do this."
All right. Yeah.
So, so I'm curious if that's something you can evaluate, or maybe it's a non-issue. Maybe it's just my perception of. Okay, I've seen lots of new equipment introduced, and it ultimately not be accepted by the healthcare practitioners, not because of what it does, but how because it impacts other things that are going on.
Yeah. We haven't really had that issue. It was more to I think through the interaction it was mostly solved. So I'm not sure how it is now. So we also want to go back now and follow up on it. But in the beginning, especially when we were there each week, it was easier to follow up and comment on these issues. I think the communication, that was the most important aspect, to communicate with everyone who's using the device, and that's what we did weekly. So I don't think if it came up, then I think they more or less solved it. I think that the issue was more the timing, and another issue that we of course had, the robot was designed to fit in the new hospital, but the new hospital wasn't ready yet. So the rooms were smaller, the ceiling was lower, you needed to be careful that the robot, if it expands, that it, the robot takes care of that, but then it stops if it's about to hit the ceiling. So these were issues that we had when we first tried the robot, because we weren't in the new hospital yet. Yeah, but...
Great, thank you.
Thanks. You have a question from Austria, from Profector. Sharat asks if you were there any situations where you had the patients in using the robot, and what did you do to convince them?
Oh, so where they didn't want to use the robot?
I think so, yes.
Yes. Good question. Yeah, there were quite a few healthcare professionals that were skeptical. I think these workshops helped a lot. So what we did was that, of course, we don't force them. So they can become comfortable, and they don't need to use the robot in the beginning. So they knew that eventually the hospital is going to shift to the robots. But there's a long period where you have the manual devices, you have the ceiling lifts and the robot. And I think that gave them a little bit more trust that, I'm going to learn it when there's time for it. So through the workshops, some of them, they just joined the workshops. They just looked at how their colleagues were interacting with the robot, were bringing up new scenarios. And I think when you're in that group, then it's easier to get involved. And then maybe your colleague says, come on, just use the joystick for once, and you use it, and it's actually not that difficult. So that this was a way to slowly get them to have these group works for the first workshop, but also the continuous workshops to get them more and more involved. And sometimes, of course, it's also when they are alone with their colleagues, so we are not there, and they are maybe not that much afraid of breaking the robot because it's only them, and that makes them feel more comfortable. So then the super users who could also educate other colleagues were also very helpful in that respect. Yeah.
A question from my side. In relation to the sustainability and also accessibility and so on. So you showed the robot for hospitals, but how affordable or how accessible is it for home usage? Because there are so many patients that is taken care of at home, and their caretakers are more open and enthusiastic to be your super users, at home. So how close are your product is to be used at home?
Not that close, because already the old hospital was pretty challenging environment for us, and that's still quite a big environment. And the home, you have stairs, you have cluttered environment, you have not enough space. So it's of course on our list, but we know it's challenging. You would need to design a complete new, smaller version for it. So it's definitely right now not on the major to-do list. But retirement homes are. So that's an area where you could use the robot, where the scenarios are also very similar. So a transfer from the hospital area to the retirement home area would be easier. Not that much work.
Thanks. I have one question for the co-creation you mentioned.
Yeah.
I think you showed some brainstorming and also some evaluation tables where you mentioned there has been stakeholders involved, but I was wondering how far does the co-creation go? How much influence can the users really have on the design process?
So I haven't measured that, but you could see the sheet, and we also put the importance of the input there. So of course every aspect that the end users mentioned, and of course the focus was more on the healthcare professionals than on the patients. They were also involved, but this was something we also wanted to develop for the healthcare professionals. So I think definitely all the things that they wanted were considered, but at some point you need to prioritize. But also that prioritization happens with the end users, so that you don't come up with something that they are totally against. But of course there are a lot of wishes when you start and you tell them, oh, we would like to develop a robot that can do this. Can it also do that? And could we get this? So of course there are a lot of wishes that all landed in that sheet, but eventually through prioritization we ended up with the main important ones. So definitely they had their say. Yeah.
Thanks. Do we have time for one more question? Okay, one last question then from my side. You said also that you used LCA for the robots or introducing it.
One robot, yeah.
I think, as far as I know, it's not been done a lot, and when so, there was a lot of trouble with the databases, non-existing databases. How would you maybe in a very short, brief sentence say how your LCA experiences are at the company?
Oh, yes. Yeah, so that was our telepresence robot, because because the telepresence robot, we just wanted to see what the footprint is, also because we advertise it that you can save flights, because you have the robot, you can log in to be in another place and you don't need to travel. So there it was very important that we check, okay, how much, what is the footprint actually from producing it. And it was a student project, so it was not that detailed, but it gave a good direction and a good basis. But it is challenging with the software programs right now, and the data there is on the sensors. Now I think with that robot, it's one of our latest robots. It was a bit easier because we have very new sensors and cameras and everything. But I can imagine that, especially for the PTR robot, where we have a lot of small components, that it will probably be impossible to find them all. So it's a challenge.
Thanks.
Yeah.
So is there a... Oh, yeah.
Thank you for considering me. Right. Thank you for this lovely presentation. I just wanted to remark on how lovely it is to see the adoption model being used correctly, the fusion of innovation, that you have your super users that are encouraging the rest of them to use, as we know that adoption always happens in waves and in stages. So congratulations on that you did it the right way around. Seems like it.
I need to go back and check how efficient it was,
indeed,
of course.
Yeah, so obviously in a few years you have to then see, but it's nice to see that companies are taking end users already from the beginning of the process. Speaking as a nurse, as a former nurse, of course,
I could see you nodding.
I heard the comment of Steve here as well from a physiotherapist point of view, but I can also give a nursing point of view of which type of devices I've seen come and go. The ones that I've seen going faster than they came were the ones that were not definitely developed not for the end user in mind, so the nurses or the hospital staff who actually sits by the clinical bedside of the patients. The devices that do have the end user in mind, so I mentioned at the panel as well the rehabilitation, what's it called?
Defibrillator?
The defibrillator, the automatic defibrillator, yes, and the chest compressions machine. What else? Anesthesia, the anesthesia devices. I've seen them take up really, really quickly in hospital environments and that are still being used. And devices that maybe, you have one or two old nurses that say, I'm never going to touch that thing. Eventually, everyone will end up using it. And I think something like this, where there is a very clear need that, and I've seen this myself happen, the heartbreak of seeing that a patient cannot be lifted because there is not enough staff to lift that patient. No nurse wants to have that. And so the possibility to do that by yourself and to quickly act when there's a need, it definitely will add to the urgency of needing to adopt this in your environment. So that's just a kind of a point of view of like what type of devices that I've seen that, and it's also nice that nowadays companies really are taking us into, I'm saying us in the past tense, but into the development process, because you then really understand what are the needs. And looking also towards the future, this fear of maybe what Paolo mentioned just before of being replaced, I don't think nurses have that fear at all. Because we know what are the things that we want to spend more time on. We would actually like to wash our patients and to have the time to wash our patients and to do those things in a qualitative way. If we can have some tasks taken off our hands that will make that possible, we will definitely take it up. Because we know that there's not ever going to be a machine that can wash a patient properly. Because as a nurse, you need to assess the patient. You need to understand, is the patient stable enough to be washed? What is happening during the whole process? The whole interaction between nurse and patient is really important there. So it might change the profession in a more qualitative way, but it will never replace us. So that's one thought that I just wanted to share.
So rather search for those situations that that are straining for you, and that talking with you and nurses that are straining, and that you don't want to do that much, and have robot support there. But like I said, even if you develop something that is totally user friendly and that makes a good benefit for the end user and for everyone involved, I think in healthcare we'll run into trouble, because we already now don't have enough personnel, and will not be able to properly introduce the robots, and that's going to be a big challenge in the future.
Okay, so if there's no more questions from the audience or from the online audience, thank you very much again, Franziska. Okay, switch mics now. Works fine? Yes, perfect, okay. So are we having a short little break now, or are we just going to the last speaker? Okay, quick coffee break, 10 minutes max, I think. Thanks. Okay, welcome back to the last part of this today's seminar. We will have Kris Verdonck on the stage with us to tell us a bit about his project. And he's the local artist from one of the two local artists in our BrIAS program. And yeah, he has founded his own company, a Two Dogs company is called. And there's been many projects, installations, performances where he tried to, I guess, put in all his brain and all his verse about visual arts, theater, and also architecture. And he will talk today a bit about the interaction relation of humans and machines, which in that context will fit nicely into the program. So welcome, Kris Verdonck. Give it up. Thank you.
So yeah, thank you for having me. Thank you for the introduction. Yeah. I will go artist stuff for the moment. So the first thing is, so I did first my architecture, but I forgot about it, and then theater. A theater space, first of all, is a very strange space. You must really imagine that there's not for nothing that in Japanese theater they call it the mechanics of dreams. It's where you produce, it's a mechanical environment. Everything is artificial. So even if we have to put light, it's artificial light. Even if it's blue light, it is, even if it's blue light, even if it's blue light, it is thought about me. There's nothing spontaneous. If an actor wants to say something or a dancer has to say something, it is rehearsed and they want something for the audience. So it's really, and it's on top of that, it's a very mechanical environment. It's a kind of, all the Baroque mechanics are there to make illusions. It's even further, if I want to communicate that there's spontaneous light, I have to put the light on stage so an audience can see that, aha, this must be spontaneous light. So it is really a mechanical environment. On top of that, it's a very, one argue that it would be the environment of human beings. We are on stage and an audience watches them. So it's really a human, if you compare them with film, that's even more mechanic, but still the real performers are there. Also, you get into darkness and all your senses are just all your mirror neurons, empathy is asked, so you have really a lot of time to see the human beings and analyze them. That's what we love to do, audience in the dark, in the idea of we see the danger, but we are not in danger. So the classic idea, the couple has a fight and you could see at ease in all security, you could see what is going on stage. So that's the theater part. And the idea of a living thing, every night is different. That's also the idea, of course. The other way around, then I did visual arts. The visual arts is a complete different thing. White space, now black space, and an object has to represent itself. An object, you go to a museum, you can, in comparison with theater, you can define your own time, you can look at the object as long as you like, and you analyze the object. That's the way you interact with it. And a normal object, that's all it has to do is be, and it represents what it is, nothing more. If we talk about multimedia, for example, this computer probably is having now talks and communication with Apple, so that it has another policy, it has a second degree of working that I don't know what it's actually communicating to the rest of the world. So when I was in school, I will show you first of all my first works. So they are a bit crappy, etc., but I think they hit the basics. The rest of the time, I only repeated what they actually contain. So once I was in school, and then my teacher said every night is unique, every time it's different. So I bought 3 tickets for 3 evenings to see what the differences were, of course. And every night was exactly the same jokes, the same spontaneous remarks, the same kind of everything the same. So I was very disappointed. If we would, that was one. And I would also love to mention also that in the history of theater, a very strange thing appears is even from Greek to Japanese to especially then a highlight was the Baroque period, Italy. Ghosts and objects were absolutely very, very important. The living object, in that sense, the Pepper's ghost was invented there. So strangely enough, although it is our place, we need objects to tell the story, which is quite crazy. So, for example, Louis XIV, he invented ballet, and it was a mechanical device that would take the women and put them somewhere all over the place. That would be the dance. That failed, and so they invented male dancers. And they would have none other thing to do than carry the women to the other side, what the machine should have done. There were no things written for male ballet dancers. On top, at one point I found a little old picture what was saying a classical ballerina with a tutu stuff, and underneath it was the marionette, which was almost shocking because how can you more objectify human beings than even calling them dolls? So at that period, I thought we have to do. I really want to do something that is unique every night, and also my little obsession by machines. So what I did at that point was, and we'll skip the first little thingy. So what I did was a classic setup, and I connected a grinder, the thing to cut bricks with an iron L, and I just plugged it in and saw and checked what happened, more or less. Do you have sound? Okay, still. So yeah, what a strange experience for me, because people were clapping, laughing, and having an emotional connection with the damn thing that burns down, which is incomprehensible that we feel and we have even pity with a stupid grinder with an L on. It's even reactions of people who said that I must have really be a sadomasochist that really likes to kill animals, etc., etc. I love trashing stuff, and it was just no, I'm not. So what is it? So what means is that really it has the same effect, not the same, but even further. If you look if you watch movies, if R2D2 dies, we're all sad, which is absolutely, you buy a new one and there you have it. Of course, it's humanized, etc. These ones I don't even have to humanize. I put it on stage, and it becomes a dramatic action without anything happening. People project on it and have feelings about it. So that was where the machine, actually, the machine takes the complete space and does the real performance. Every night completely different. It burns every night differently. I couldn't control it. Sometimes it got a short circuit in 10 minutes or the next second, and it was also finished, and I failed, and not everybody was happy with that. So the next question was, so how can I, if I put machines on stage, how can I put human beings in a museum context? Really completely switching places, and I could not kill actors because they're protected kind. There are too many of them, we know it all, but so yeah. So here a sensory deprivation tank, 2 meters on 120 on 120. The water is 30 degrees exactly, and the performer stays in. Here he is. Heartbeat and respiration are in real time. The actor, because of the environment, I saw it always as a complete exoskeleton where actually the object pushes the human being inside of where it takes complete over the condition of this human being. So the performer gets into a trance, doesn't hear, doesn't feel, doesn't see anymore, completely relaxed. It's even fun to do. So yeah. So from now on, from that moment, I always tried to switch from the other way, the performances, machines, and the human beings objectifying and seeing what is going on. So I would go for another one, so a little, this one, for example, on performance, on the idea of performance as an engine that performs. So here we have, for example, do you have some sound? Yes. A V6 engine. Don't crash here. And that's the crash. No, machines don't like to perform. Yeah. So can we change? So I had a V6 engine, Alfa Romeo. It had to be an Alfa Romeo for one of my technicians, and I put it the machine. Am I back? Am I back? Put it as loud as possible. It goes from 0 to I don't know how many tours per minute, but it really performed with a. I'm just gonna plug it out, the whole damn thing. Am I? Yes. Tack, tack. This is not good, but we'll see if they survive. Ouch. This one there. This one here. This one there. Thank you. Allow. And not this, but yes, that. Ooh, it's not really what I was looking for, but this I was. And why does he not read? I can't open my file.
It's in here? There is
Two. I will do it for this one. Will work.
Will it?
Yeah, it will work. Let's try with this one. So, here you have the V6 engine, remote control, and I just showed it as an object. Even there, people asked me at one point where the cables were and how did it work and did I needed electricity. Also, people said, which is very, very strange, somebody says you're polluting, and also this is not in my car. Completely no imagination anymore that this was part of their daily work. Another one. The thing is, here is, for example, this was a box 4 meters on 4 meters, 120 high more or less, filled with heavy smoke, and we could control by a lot of little ventilators the smoke. The thing is, as an artist, you always have there's a thing is that the main question in the whole history of art, the main question is what is the object, what's the material, what is the politics of that material, and trying to develop it even further instead of me wanting something from the object. It is much more a big question, what does the object want from me? In the sense that if you look, for example, to these little stupid little scooters we have in Brussels, so many of them super dangerous, the question we could pose is, why do people drive crazy with them? Well, the answer is very simple, because you can. The way of driving with a bicycle is something completely different, and you take much more less risks. It goes less fast. It goes less. So actually, the way of driving is completely already inside of that machine. I say probably different things because this microphone is pushing something for it. Asks something for me. This machine-like environment. Completely, it's always, for me, it's always the other way around. For me, the most interactive machine is probably the teddy bear. The teddy bear, it's of course all projection. There's nothing interactive to it because, well, yeah, it's just an object. But the intimate relationship and the projection of this doll is just amazing. It talks back. You tell your biggest secrets. Everything is present. And I think the projection of what we have, how the projection on the machine and its return, I think in that interaction, there's something I think very, very valuable on. Instead, for example, how the environment will change if you have a robotic. Such a robot in your hospital, everything will change. And it's for us to discover what it actually is. First of all, you have this object, and then it will start to propose things that it has its own language. It starts to change the environment. It starts to change behavior, and often we cannot guess as makers what the machine really does. I am very sure that these little machine guys, the step guys, did not think about the amount of broken feet and heads. They just didn't think about it because it just unveils itself while doing that. And sometimes it's even years before a machine or an object really is showing its influence on society, on us. And that I think is so. I really am convinced that we cannot underestimate the hidden politics of a machine, of a social economics behind it that slowly unveils itself. So this is Heart. Can you put it loud? So actress, performer, alone on stage. Heartbeat again in real time. Again, this is one of the first performances. So she's pulled backwards, 8 meters backwards, 4 meters high, smashes into a mattress, falls down on the next mattress on stage, goes back on stage, waits for the next 500 heartbeats, and it's the heart actually that is the motor of this hellish cycle she is in. She's doing it completely to herself in that sense. She doesn't know when the jump will come, because even counting doesn't really help. And as a spectator, it's all the machinery of the theater. It's actually producing this drama. It's actually fun to do. I've never wanted to hurt my performers. I only wanted to put them in a system, and as an audience you can watch it like scientists, how behavior inside a mechanical environment works. This was also one of at that point the mobile phone was just invented. Yes, I'm so old. And just the idea that until then you could walk on the street very freely without anybody could reach you. And suddenly everybody just had the power to grasp you from the street and connect to you with bad news, and there you go. Another thing that I'm really interested about is that if one has, of course now, thanks to Apple, we all bring our mobile phones into our beds, and if one has a intimate problem, the craziness is that your little problem, the asked thing, you don't dare to say it to your partner, which is actually a real intimate person. You don't say it. You first Google it. So sometimes you yell it to the world, not really, but almost, say that you have this little problem, and then days later you maybe say it to your partner, which is absolutely crazy. But just it's again the feeling of intimacy that this object produces. Thank you, Steve Jobs. We must also imagine that Steve Jobs invented this kind of interaction with this machine after he went to Disneyland, working in Disney World, and there he invented the kind of idea of make the film of your own life. Not any, he started with all this creative stuff that actually made this thing so big. So this is, for example, 1, 2, 3, 4. It's a dance performance, solo, duet, trio, quartet, and this is actually the dream of Leopold. From Louis XIV. So we have the dancers on strings, and here now they're hovering. What I did in this performance was, so there was a whole mechanics to lift them up. The 4, it was almost 50% more or less random. So the dancers could not really control all the machines, and so they had to learn to dance with the machine. So the whole rehearsals were just these dancers searching all possibilities and having a connection with them. And at one point, this one of the dancers was upside down. Did a movement, and it was really nice, blah, 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 blah. Everybody was happy with it. Another dancer tried it, and then this first dancer, the other one tried it, couldn't do it. The first dancer, they were in discussion, and at one point this first dancer didn't know anymore how to explain how she did this movement, this particular movement together with the machine, that she said, well, just listen to the bloody machine. Which I thought was extremely interesting. If we talk about robotics, if we talk about extensions, exoskeletons, and so forth, etc., etc., it's actually these machines have their own policy in them. They push a way of thinking, they push a way of moving, and I think on a long term, this is actually the thing that will be produced by this machine. So, for example, here. This movement is still produced by the apparatus, and then this one still also, and that's why they're so beautifully parallel. but now they start to control, and we go slowly berserk, of course. Things will go wrong. They do everything to be parallel, but of course that doesn't work anymore. It's just humanly impossible. For me, one of the I saw at one point at Bolshoi Theater, I could see these amazing ballet dancers doing the swan leg. But it was a rehearsal, and all these super athletes had still their normal trainers on, while suddenly they were human beings. Suddenly they were real beautiful human beings, which was completely strange in that environment. So these kind of performances, then on the object level, I have to search a little bit now. I'm looking for bogus. Where is it? Yeah, bogus one. Here we have, this is without sound. So we have four boxes. Yeah, sound. There are inflatables coming out. Here they are. And they go up until 8 meters, and then they crawl back into their cases. I don't know what that sound is, but yes. So here they, like dressed characters, they go back down in their cases, collapse and go back up. Yeah, and it goes on. Here we have a little dancer number 3. Yep. So this one is, for example, yeah, can we have sounds? This one was a little jumping robot. It was for 60% in random. And when it fell, there was another machine that put it back on stage, or put it back straight. And then it started to jump around. It was maximum speed time. Yeah, there we have it. Again here, it is cute, due to the sounds for sure. I never know when it falls, when it's straight. Again, people are so connected to it. And again here, it is 80%, I guess, projection, and the machine itself does actually nearly something. It's sometimes amazing how this empathy, how these mirror neurons work. I will show you here. I hope to how powerful these. Do not underestimate how strong the influence of somebody like me can have. This was a performance where I thought, I'm really going to push now. Can I put the audience to sleep? Can I really do it? Do I have such an amount of power on them? Yes, I can. This I really don't know. So anyway, AIXC is dancing. So first we had people had to have these pillows, because first I wanted to do it without pillows, of course. But then people were so angry at me because they slept so, they were all like aeroplane things, and so I didn't really want that. So then I thought, like, okay, give them pillows, it will work. I talked with a hypnotist, on what's the strong, why does hypnosis work? It was a hypnotist that was also a doctor, so he did this hypnosis where people had operations under hypnosis, and it works. There's not so much doubt. So he learned me how words, how dramatic lines underneath so-called innocent texts work so far that you can operate somebody and that person hasn't got pain anymore. So strong words, they are happening. No. So believe me, I wanted to show you. I'll just wait for a moment until maybe it does something still. So more or less 80% of the audience was really just off to sleep, even with the back to the stage. What we did was all elements of this performance, light, sound, movement, text, even the little video, all was part of one session of an hypnosis show. So I can't do anything. I will do this then. Up. Will that work? This is very strange. It's somewhere in, but I don't know where. I will just do this. Up for a moment. Yeah, I know. Even your computer is dead. Yeah, most of the time I do these things with the objects. Probably yes.
Do you need a Mac?
But I can get mine back. Let me see if I can do anything. Is this something? Yeah, I can just show you sleeping people. That's not very interesting, but what time is it? Where are we? Yes. So this is also one of the I could go on and on and on. I've got so many variations on how objects influence human beings and what the policy is, what the politics are of machines. And that's also one of the things I with all due respect for all what you guys all invent, but for me, these to try to, what I miss is the exercise of knowledge on what the politics are of the inventions. And that's my call, more or less, for the BrIAS. If I have anything to add, is to really try to watch your machines and try to observe them and try to understand what they really mean. If we take Van Gogh, for example, everybody said he was completely mad because he tasted his, or he ate his paint. Well, it was not really because he was mad. He wanted to understand what paint is. For example, the David, Michelangelo, the David is a bit turned, and that was because he found while sculpting there was a little crack inside of the stone, and so he had to sculpt around it. And so it's actually the stone itself that said much more about how the David, not really, but it defined so much more, and not to be underestimated, what the influence on the stone of him was, more than the other way around. And I think all the objects that we are surrounded with have a kind of politics inside, and I think it's worthwhile to try to be aware of, pay attention, as they call it, about what we are inventing. Thank you.
So thank you very much. And there are questions?
Yeah, I'm just curious to see. You talked about percentage of randomness in your works. Do you decide this, or you object machine decide the level of randomness?
Yeah, for the dancer, for example, the guy who was programming it, at one point I call it even egoless watching. So I really asked to all the technicians to try to observe what the machine wants, and this little robot had a kind of rhythm that the robot really liked to do. Then it was imbalanced, then it was half imbalanced, then it was the most interesting. So we tried to push the object towards this kind of performances, this kind of jumps, because it liked it. And we don't even humanize it. There's no. It's pure technical. If I have no emotional connection with my machines whatsoever, they can burn down. I don't care. As long as I have the money to buy a new one, it's good for me. So we really try to understand the thing that sleeps inside of the machine, what the politics are. So if it's 60, and then of course I will try to get 50% life. The more I also notice, the more I'm close to the object, to what it wants from me, the more it gets layered, the more interesting it gets, the more all the materials start to be alive, if you like. It's not so important. I hope always, and I'm getting there sometimes not, that I am not necessary anymore in the project, that we just have to follow the materials and the policy that is inside of the object already from day one, actually.
Okay, other questions?
Thank you for the presentation. This may be a difficult question for you to answer, but when we think about this relationship between humans and machines, and I think you're trying to share with us clearly that sometimes the machines shape our behavior. How do we decide when we think it's, when we say okay that the machine is shaping our behavior, or when do we back off on a machine because it's shaping our behavior?
Yeah. Sir Martin Rees, Royal Astronomer, good friend of Stephen Hawking, this kind of level, he wanted to organize, as a joke, a group of people that could decide if a invention could continue, yes or no. If it was worthwhile, if somebody said, like, I want to create an atomic bomb, shall we or shall we not? And of course, you feel immediately that it is impossible to stop things. We are a curious specimen that are relentless in our curiosity, and so what we will invent, what we can invent, we will invent. You see it now in AI, also artificial intelligence. You can see the we don't really care what the policy is not even talked about. It's not enough talked about for me. What it means, what the influence is. Now you can feel people are being a bit suspicious about it, etc., etc. But people can be as suspicious as they like. There's a rat race, a real race between nations. China, United States, blah, blah, blah. Everybody is just going for it, and there's nearly room to think about consequences. Actually, this is one of the things that I see happening almost every day in my life, that there is no real morality, or there's no real stop, or it's not even the question if we can continue, yes or no. We will if we can. And this is something, if we technologically can do something, we will do it, because we are so curious what it will do. The consequences of the for now, for example, the hype around the electric motor, electric engine, or the electric car. Yes, of course, we try to take the batteries back, etc., etc. But a bigger or a larger scale, I think, it's I just read a couple of days ago that it's the biggest invention on that scale that will completely change everything. But this is the first time that it happens on that scale, on a global scale. A new invention is on mass produced. Everybody likes it. Everybody wants it. I'm working now, to give you an example, I'm working now on to blow up an engine, another one. And I can't find mechanics anymore, because in schools they don't teach anymore the old mechanics. Everybody wants to go electric. That's the thing. That's what we're going for. You cannot stop it. So there's for me there's a kind of this energy to invent things is nearly stoppable. So there's even not a discussion on for me there's not even a discussion on shall we or shall we not. We will, because we can. Will we replace human beings? Well, as much as we can, of course. It's very cute that I sometimes hear this kind of, shall we, yes or no? Pff, of course you will. Oh, you don't even have to bother me with that kind of... it's cute that you guys do it. If I replace my actors, it just also works, huh? So, yeah.
Other questions? No? Okay, thank you very much again for this nice talk. And I leave the word to Michel for the final remark.
Yeah, I don't have any further remarks. Thank you very much for your presentation, Kris. Thanks a lot. And thanks the audience here and in the World Wide Web for joining us today. And I'll see you next week. Bye-bye.